stuff. The final chapter is usually final section of each chapter is called modeling, which is big picture, applying it to the real world.
Okay.
This is applying differentiation to the real world. Differentiation is all about finding the rate of change. We've been doing the rate of change in y with respect to x. It could be the rate of change of volume with respect to time. So you have water flowing into this thing, so it's at some rate it's going up. You also have some water flowing out, so at some rate it's going down.
Okay.
They use these methods for modeling virus outbreaks and stuff. So this is new people getting sick. This is the amount of people who are sick at the moment, and then this is people who are no longer sick, and it's all very maths. All right, this is not gonna be easy. Okay, example 22. Let's try A. Show that the volume of this tank is not easy. Let's see. I'm gonna need a diagram. I'm gonna use this one. That's my diagram. Let me just see. I'm gonna let's start with this. Okay, how about this one?
Okay. Wait, so we just sub in 5 for R?
That would be to find the volume. We want the rate of change of volume. And so to find... can you hear me
I
again?
can hear you now.
Okay.
Yeah.
R5 would give us the volume when the radius is 5. We want the rate of change of volume when the radius is 5. And so rate of change is dy dx, or in this case, applying it to real world, instead of dy dx, it is dv dr.
Oh, okay. Wait, so it's 4 over 3 pi r cubed over 5?
It is differentiate. So if this was y equals 4/3 pi x cubed, what would be dy dx?
4 over 3 pi 3x to the 3x squared.
So and it would be times by 3. So power times coefficient. Can you hear me? Hello?
Right.
Sorry, you're back.
I can hear you now.
Okay.
Yeah.
So what was the answer, sorry? Or did you get one answer?
I said 4 over 3 pi 3x to the squared.
Yep. And we usually, so what is 4 over 3? So that's 4 over 3 times pi times 3. What is 4 over 3 times 3?
4 over 3 times 3. 4.
Correct. And so, yes. How about this one on the left? It's volume and radius. This is the volume of a sphere.
So it'd be 4, it'll be 4 pi radius squared.
Correct. What is the rate of change when the radius is 5?
So do we sub 5 into 4 pi r squared,
Correct.
which gives you 100 pi.
You're right. 100 pi. Fine. That's 5 squared. So it's exactly 100 pi, and then it's roughly 314. 3.14 times 100.
Yeah.
Okay. That is going to be the rate of change. So that will be 314 centimeters cubed per centimeter, I think.
Yeah.
Centimeters cubed per centimeter. Yep. Okay. Dy dx, change in y with respect to x. And so now it's dv dr, change in volume with respect to radius.
Yeah.
It's an expanding sphere. So first it might be like that, and then after a while it's like that. You know,
Okay.
that type of thing. Okay.
Yeah.
We could do this. So there's a million questions and they're all very similar. Okay. I put them in this order for a reason, I'm sure. So let us go back. So this is a large tank. It's a cuboid. Hold on. So this is a sphere. Nah,
Yeah.
I won't spoil the surprise. Okay. This is a large tank. And it's sheet metal is that. It has no top. Okay. What is the surface area? No. What is the volume of this tank?
Base times width times height.
Yeah. And so what would that be for this one?
That would be. Well, we don't know what the height is.
Height's x.
Yeah, it's x.
So let's
Oh,
just
okay.
in terms of x and y. What's the volume?
Well, we know it's 54 meter squared sheets of metal. Sheet metal.
We'll get there. That's area.
Oh, okay.
Volume.
What, y times x times x?
That's it.
Or y times x squared?
Yeah, I'll just do it alphabetically. X squared y. Looks a bit
Okay.
weird. Volume is x squared y. So if they said find the rate of change, in the previous one, the rate of change was dv/dr.
Yeah.
If they asked us to find the rate of change here, we would be tempted to say it's dv by d, and we hit a snag. It's not dv by dx because there's a y.
Yeah.
It's not dv dy because there's an x.
Is it m squared?
Say it again.
M squared.
That's meters squared. That's just the unit.
Okay.
That's the problem. Okay. So basically what we have is a simultaneous equation. We have but we only have one equation. We need a second equation, and they give us a value to do with the surface area. What is the surface area of this cuboid? And it has no top, it says. So we want the surface area of each face.
Oh, so it'd be x squared.
Yeah.
X, y. Oh, no, wait, would it just be... Would the x's all be put together into, like, x squared, same with y? It would be x to the power of, and then a number.
Well, let's see. So on the right side, it's x squared. What would
It'd
it
be two x's.
Yes.
So, and then like the side would be y times x. So it would be x cubed y so far.
Well, hang on. Let's just take it. So the right side is x squared. What's the left side?
X squared.
And so in total?
X to the power of 4.
That's times. It would be 2x squared.
Oh, right, okay.
You're just adding those two together.
Yeah.
How about the front and back?
It would be 2xy.
Yeah. And there's no top, and so how about the base? The bottom.
xy or yx.
Yes. Huh. So that's
So would it be 3xy?
So that's actually 3xy, yeah. Okay, so the surface area is 3xy. They also tell us that the surface area is 54.
Okay.
And so that's 54. The problem was we had a y over here that we didn't want. Make y the subject. What would it be?
What, so would you divide by y on both sides?
Well, sorry. We have to get y by itself. And so how
Wait,
do we...
for which equation? V equals x squared y, or a surface area equals 2x squared plus 2x?
Surface area.
Oh, okay. What, so we just minus 54 on both sides?
I would keep the y where it is and move everything else away from it.
So we can minus 2x squared on both sides.
Yeah.
And then could you divide by 3x?
Yeah.
And give you y, that's what y equals.
Okay. And so in our first equation, we wanted dv dx. The problem was we had a y. We wanted not a mixture of x and y, but just x and an x. What could we do?
Wait, so do you want x on the left of the equation?
So for volume, we wanted to somehow eliminate y. So there's no y, just x's.
So we just divide by y on both sides?
It'll still have a y in it though.
Oh.
We want v equals just x's. We want to eliminate y, and we know that y equals 54 minus...
Oh, so do sub in that into for y?
Correct. There we go. So it's not pretty, but okay, hold on. So far so good. We wanted to... Right, 1 second. Go back here. We wanted change in volume with respect to radius. We did dv, dr, subbed in our thing, got our answer.
Yeah.
This one, we wanted to change in volume with respect to x. We tried to do dv by dx, but there's a v is equal to a mixture of x and y. And so we had two unknowns, two variables. So we needed a second equation. They told us surface area, and so we created an equation with surface area by finding surface area in terms of x and y, making it equal to 54. Make y the subject, and then sub that into the other one. So we could go from a mixture of x and y to just x and more x. And so now we can do dv by dx because we have just x's. Before we do that, let's try to simplify it. So finding dv dx.
So can the bracket simplify? The 2x squared and the 3x? And wait, do we times everything in the bracket first?
Let's do that first, yeah.
Okay, so it'd be 54x squared minus, would it be 3x? Would it stay as 2x?
2.
2x to the power of 4.
Yeah.
And then over. Wait, pardon?
Yeah, sorry. That's all over 3x.
Yeah. Would it be x squared times 3x?
X squared times 3. One way you can deal with this is to so over 3 is the same as a third.
Yeah.
And if x, do you remember how you would deal with how you differentiate if it was like x squared minus x to the 4 over x? Do you remember how you'd deal with that?
No.
We would say that is x to the minus 1, on the
Oh
bottom.
yeah. I remember now. Yeah.
So instead of times the positive, instead of divide by the positive, it's times the negative one. And so we do the same for this one. That is over 3 is the same as a third.
Yeah.
I'll just help that bit. Okay, what's next?
Wait, so would you differentiate it, or would you multiply that by everything in the bracket first?
I'd multiply first.
Okay. So would the first one be 18x
Yes, very good.
to the power of 1, or just x, 18x?
Yep.
Minus, and then third. Minus 2 over 3 x to the cubed.
Well done. And so we now have v in terms of, instead of x and y, x and x. What is dv by dx?
Okay. So it'd be minus 2 to the power of 2 for the second part. So it'd be 18 minus 2
Yep.
to the power of 2. Or x to the power of 2. Yeah.
And let me just see. Show that this can be written as 18x minus 2/3 x cubed. So we did that. 18x minus 2/3 x cubed. That's what we got. Given that x can vary, use differentiation to find the maximum or minimum value. So how could we now find the maximum or minimum?
Would we differentiate it again?
That would confirm that it's a maximum or minimum. What do you know about a maximum or a minimum?
What the gradient has to be.
Yeah, what is the gradient?
For like the maxima, it has to be minus. It has to be less than 0.
That's second derivative. So at a maximum, what is the gradient?
0.
Correct. The gradient function is dy dx or dv dx in this case. And so the second derivative isn't equal to 0. This first derivative is equal to 0.
Yeah.
At a maximum or minimum or point of inflection. And so solve this one.
Okay. What, as a quadratic?
Yep, that would work.
I got x is 9 and x is 0.
No, I think you did minus 2 and 18 and 0. It should be minus 2 and 0 and 18.
Oh, okay. Oh, yeah, it is. Yeah, sorry. I got x is 3 and x is minus 3.
That's it. 2x squared is 18. 1x squared is 9. X is plus or minus 3. Let's see this one. Given that x can vary, so at its... yes. And then we have to find which of these is the minimum, which of these is the maximum.
Oh, the minimum is the x is 3 and the maximum is minus 3.
The minimum is the value of... It depends on the value of the second derivative.
So we work out the second derivative?
Yeah.
Okay. So it'd be just the second derivative would just be minus 4x.
Yeah, minus 4x.
So you substitute 3 into for x, which would give you minus 12.
Yeah,
And the other one would just be 12.
Yeah. So that one's less than 0. Therefore,
it's a maximum.
correct.
And the other one's a minimum.
That's it. And so, what value of x will give you the maximum volume for this tank?
What do you mean? What would it be? 12?
No. What was x for the maximum?
Oh, x is minus 3. Wait, no, x is 3.
Yeah, for the maximum volume, x is 3.
Yeah.
And so the manufacturers of this large tank should make it 3 meters by 3 meters by something else. That would maximize the volume for the amount of sheet metal they have.
Yeah.
And that's the practical interpretation of this differentiation, or one of them. But very big picture is you get 2 equations involving the solid or the shape. You sub one into the other, so that you go from having one equation with 2 unknowns, 2 variables, to one equation with 1 variable, which you can then differentiate.
Yeah.
But it ain't easy. Okay, let's try this one.
Okay. So do we need the surface area again or not?
Yep, surface area would be one equation.
It would be... Well, would the height just be h then?
Yeah, for the moment height is h.
Okay. So it'd be x squared. Wait, no, 2x squared. H squared.
You're thinking of volume. So no, hang on. There's no square. So
2x. It's to be 2xh.
yeah, so 2xh. That's the front and back, I suppose.
Add 4x. Would have been, but it says 2x for the length.
Nothing wrong with that. And so, what's the area?
For that, it would be height and 2x. It'd be 2xh.
Yeah, and in total?
4xh.
So 4xh, and the floor, the base.
3x.
That would be if we added them.
2x squared.
Yes. Simplify.
6xh plus 2x squared.
X squared. Okay. We are also told that the volume is this. How can we use that?
We turn it into equation, so it'd be base times width times height equals 4,000. So it'd be base, which is 2x, times, so it'd be 2x squared times h. 2x squared h equals 4,000.
That's it. Okay. So part A is find an expression for h in terms of x. That means h equals.
Okay.
In terms of x.
So could we just divide by 2x squared on both sides.
Yeah.
So it'd be 4,000 divided by 2x squared.
Yeah. And can you simplify?
Would it become 2,000 over x squared?
Yeah, and that might become useful later on. That's a bit okay. Part B. Show that the area can be written like this. So it's similar to R1, 2x squared, 2x squared. We have 6xh. They have something else.
Okay. So can we substitute 2,000 over x squared for h in 6xh plus 2x squared?
Correct.
So it becomes 6x and then 2,000 over x squared plus 2x squared.
Yeah.
And then you can simplify, you can multiply 6x by the bracket, which gives you 12,000x over 6x cubed.
6 is the same as, what is 6 divided by 1?
6.
And so another way to write 6 is as 6 over 1. So you just times the bottom by 1, so that just stays the same.
Oh, okay, yeah.
And can you simplify anything there?
X's cancel out.
Yeah, and I'm just going to swap them for the question because they wanted it written in a specific way. So I'll just put the 2x squared first and the other one second. 12,000 over x squared. Oh, sorry, over x. Question C.
So it wants us to work out the surface area using differentiation.
Yep.
Okay.
No, just the minimum value of x.
Okay. So what equation do we use? Do we use 2x squared plus 12,000 over x?
Yes. The thing is, this one up here, the a equals.
Yeah.
If you try to differentiate that, you try like dA by dx. Problem is you have a h, but now that we subbed in the h from our other equation, we now just have x's, and so we can do dA by dx.
Okay. So it'd be 4x plus 12,000 over x.
12,000 over x.
Would that just be 12,000?
That's the same as
x. Oh, yeah.
So what will be the derivative of that?
Minus 1 or minus 12,000. And then minus to the power of minus 2. X to the power of minus 2.
Okay. Question D.
Okay. So do we get the second derivative first?
What do you know about a minimum?
It has to be positive or above 0.
The second derivative is greater than 0.
Yeah.
Anything else you know about a minimum?
It's equal to 0.
What's equal to 0?
The first derivative.
Correct. First derivative is equal to 0 at the minimum and maximum.
So can we solve that as a quadratic or not?
No, because it is
Negative. Okay. So you can't solve it as a quadratic manually either?
You could. 12 12,000 over x is the same as 12,000 x to the minus 1.
Yeah.
What is 12,000 x to the minus 2?
Is it over 2x or x squared?
X squared.
Yeah.
So that is the same as 4x minus 12,000 over x squared equals 0. And so how do you solve that one?
Does that not work in the calculator?
The problem is it has a fraction. What you could do is times everything by x squared.
So if you times everything by x squared, it would be 4x cubed.
Yeah.
Minus 12,000 equals 0.
Well done. And that's what you would solve.
Okay. I got x is 14.4224.
Let's see. 3. Yeah. 14 point something was it?
Let me check. 14.4224.
So let's say 14.4. And then part E, show that that is the minimum.
Would you get the second derivative first?
Yeah.
Okay. So it'd be...
and you could go back to the power minus, make it easier.
Yeah. Wait, so would it just be... Would it just be 2 times 12,000?
Yep.
So it'd just be 24,000. 4 minus 24,000x. Oh, no, x to the power of 3.
1,000 x to the minus 3.
Yeah.
Okay. And how do we show that it's a minimum?
We can make it 4 minus 24,000 over 3.
Over x to the
X
3?
cubed, sorry.
And then you solve it. Make it equal to 0 and solve it.
Yeah.
No, sorry. Then you sub in your value of x, don't you? Yeah.
Wait, now? Right now?
Into the double derivative, yeah.
Okay, so it'd be 4... Okay. So can I just put the whole thing into the calculator?
I think you'd have to sub... Yeah, you could, but you have to sub 14.4 for x. So
Yeah.
Yeah. I just ran out of space.
I got minus 4.04 to 3 significant figures.
That implies that it's a maximum. 14.4. 14.4. Oh, of course, that's why. Because the minimum area is when x is 14.4. But what is the area? The area, you would first have to sub 14.4 into that one.
Which one?
A equals...
Oh, right, yeah.
So all the x's, put 14.4, that answer into there.
What, with the h as well? Well, the h will be left over.
So we use the one with no h in it. And that's part of the benefit, that we don't need to know h.
Oh, so we use 2000 over x squared?
Yeah.
Okay. I got 4.823.
Yes, so that is, so the area, the minimum, let's see, so the minimum area is when x is 14.4. When x is 14.4, the surface area is used is 4.82, and we want to use as little surface area, like as little material as possible, to maximize the while still maximizing the volume inside. Let's see. And what was it saying? Find the minimum. Show that your value is a minimum. Double derivative. Let's see. This one here, when we had the x to the minus 3, you actually just solve that, I think, and you get x equals 12. No. All right. I think it's all right. Yep. Any questions there?
No.
So it's just long and brutal. So I want to do one of these that let me just see. So this is very similar. I'd like to do, yeah, cylinder. We need to do a cylinder one. So this one is similar. Yeah. Okay, let's do cylinder. So it's cylinder, so it's going to involve pi. We did a little bit of something to do with this earlier. That was a sphere. Okay, so this is cylinder. How do you find volume of a cylinder? Do you know?
Is it? Height times. Oh wait, is it? I'm thinking of a cone. I forgot the equation for a cylinder.
It is, what's the area of a circle?
Pi r squared.
And so it's just pi r squared times the height. So pi r squared is the area, and there's height number of those. That's the volume. Do you know surface area of a cylinder?
Is it 2 pi r squared times height?
It'll be 2 pi r squared plus the surface there.
Okay.
That will be the height times
Pi r squared.
times the circumference. Do you remember circumference of a circle?
Isn't that like diameter times pi or something?
Yes. Diameter is 2 radiuses. I'll write it as 2 pi r because we have 2 pi r here.
Yeah.
So 2 pi r squared plus 2 pi r h. Okay, so we now have 2 equations with 2 variables, radius and height. So we think we have everything we need. Let's try this one.
Okay. So for the volume, do we want something else to be the subject instead of V?
Show it the volume. No, they have V as the subject. The difference is we have R and H, they have just R.
Oh, so we want H for the H to be on the left.
We don't want any H. They don't have a H on the left.
Okay. So do we divide by h both sides?
Let's see. So you see we get h equals in the area one, and we sub it into the other one. We get h equals, make h the subject in the area formula, and then
okay.
sub that, yeah, to eliminate.
Wait, so can we divide by h on both sides then, or would that not work?
I would start by adding or subtracting. It's easier. So
subtract 2 pi r h on both sides.
Keep the h where it is.
Okay, so subtract 2 pi r squared on both sides.
Yeah.
So it'd give you minus pi r squared equals, yeah.
Equals 2 pi RH. Okay, so we want h equals.
And then we can divide by 2 pi r on both sides, which gives you minus 2 pi r squared over 2 pi r.
And don't forget there's a minus.
So it'd be a, wait, it would be a be on the top then?
Yeah. And what is a? What is the surface area?
Is 30,000.
Yeah. There we go. And so that is h in terms of r.
And then can we simplify?
Yeah. How could you simplify that?
So it'll give you minus r. Like minus pi r squared and the 2 pi r.
What I would do, because it's a bit precarious, is let's just half everything.
Okay. So it'll give you 15,000 minus pi.
Minus pi.
And then pi r.
Yeah. So minus pi r squared over all over pi r.
Mm-hmm.
So I see 15,000. I see 15,000. It's looking good. Okay, what's next?
Can we simplify it further or not?
Let's not. Let's, because we might make a mistake.
We sub that the whole equation for h in the volume equation.
Yes. And so what would you get for that?
You'd get pi r squared times 15,000 minus pi r squared over pi r.
Yes. And so now we'll simplify this.
Mm-hmm.
Over pi r. And in fact, if we simplify it correctly, what should we get? Or go on.
15,000 r minus pi r cubed.
Yeah. And so if you're not sure, you just write that, because you've gotten, you have effectively shown it.
Yeah.
It's not too difficult. You have pi r on the bottom, so you divide by pi r on the top, and so you're left with just 1 r.
Yeah.
R times 15,000, 15,000 r, and then minus pi r squared times r minus pi r cubed.
Yeah.
Okay, so we showed that the volume can be written instead of pi r squared h as 15,000 r minus pi r cubed. We've shown that the volume can be written instead of a mixture of r and h, just r. Part B.
So to differentiate 15,000 v minus
r, sorry.
Ah, okay.
Yeah, differentiate dv by dr.
You'd get 15,000 r minus 3r squared.
What happens to 15,000 r? This r goes away.
How come?
What do you get when you differentiate 3x?
Oh, yeah. Oh, yeah. Wait. But it has no power.
So it's like to the power of 1?
Oh, yeah, it gets rid of it, doesn't it? Yeah.
And anything to the power of 0 is
Yeah,
1.
I get it.
Yep. And the other one is, don't forget the pi, minus 3 pi r squared.
Yeah.
That is dVdr. We're trying to find the minimum.
So can it be...
What do you know about the derivative at a minimum?
The minimum is always equal to 0.
What is equal to 0?
The first derivative.
Correct. Okay, we want... Yeah, solve it.
So could you do minus 3 times... Oh, just... Could you do that? Minus 15,000.
You could put it in the calculator. It'll give you a decimal. It won't give you pi, but I think we'll be okay with that. Yeah.
I got 39.894.
And so 39.894. And what is that?
That's R.
Okay, so they asked us for the volume. Is that the volume?
No, that is R.
Yes, that's the radius. So how do we use that to get the volume?
Do we substitute into V equals 15,000 R minus pi R cubed?
Well done. And you can use answer if you have it saved as the answer.
Okay.
I'm not sure if you do. You can check just by pressing answer equals and see if it
Yeah, I do.
Okay.
I got 39,800. No, 398,942.3.
Sorry, 398,000.
942.3 to one decimal place.
I'm going to say that that's roughly 399. I'm saying 400,000. What do I care?
Okay.
400,000 centimeters cubed. Show that your value is a maximum.
So now we need the second derivative,
Correct?
which gives you minus 6 pi r. 15,000 minus 6 pi r equals 0.
What is the derivative of 15,000?
0.
Yeah.
So it's just minus 6 pi r.
So that's d squared v by d r squared. Is that how you do it?
I think so.
Minus 6 pi r. Okay.
And then would you substitute r?
Yes. R was roughly 40.
Yep.
What number will we get? Positive or negative?
Pi times 40. Negative.
So that will be less than 0. Therefore,
Therefore, it's a maximum.
yes. The derivative is equal to 0. The radius of the maximum is roughly 40. The volume, the maximum volume of this cylinder is 400,000 centimeters cubed.
Yep.
400 liters, something like that. And the second derivative is negative, so it is definitely the maximum.
Yeah.
Okay. Let's see. Therefore, it's a maximum. It's negative 399,000. All right. I'd better go with the 399,000 sig fig. Any questions about that?
No.
Okay. Very, hang on, very big picture. So we did a straight edge, we did a curved edge. Very big picture is find the maximum volume. That's easy, dv by dr, but it had a h. Get a second equation, make h the subject, sub it in. So you don't have a mix of two, you have just one.
Yeah.
This is volume and surface area because it's 3D. This is volume and surface area because it's 3D. Volume and surface area because it's 3D.
Yeah.
This is 2D, so it's going to be perimeter and area.
Yeah.
Those will be the two. Same idea. This one is just more complicated, but same stuff. This is going to be what two equations will you get for this one? Or what two types?
Area and surface area.
Those are the same thing essentially. They're both area.
Oh, perimeter and area.
Correct. Perimeter and area because it's 2D.
Yeah.
And it will be the same idea. Sub one into the other, and then you can differentiate. Find the maximum area, you know, same stuff. And then we have mixed questions. And so what do you give yourself for that one?
Probably between a tick and a half.
So that's great because that's a very tricky thing. I had a sense it would take a while. And it did. But anyway, let's see. Yeah, so differentiation, you know, you're pretty good at it. Stationary point is when the derivative is 0. And the application of that to the real world is the stationary point is when the derivative is 0 is when it's at its maximum or minimum. Yeah. Very common that someone who manufactures a tin or something wants to maximize the volume for the minimum amount of material used for the minimum surface area. That's what it's all about. Let's see, it's changing stuff. Let's just see. Yeah, that's all right. Yeah, how was that for you, Adam?
That was great.
So that's chapter 12 done. And so chapter 13 next time.
Yeah.
And that's integration. Integration is the opposite of differentiation.
Okay.
Any questions for me in general?
No.
All right. Well done, Adam. You did
Thank
great.
you.
And I look forward to talking to you again next time.
You too. Bye.
Cheers. Take care. Goodbye.